Something massive is lurking at the frozen edge of our solar system, silently altering the paths of ancient worlds. For centuries, astronomers believed our celestial neighborhood ended with the icy, sun-bleached rock we call Pluto. Yet, far beyond the Kuiper Belt, extreme cosmic objects are behaving in ways that defy established physics. Small, frozen bodies orbiting past Neptune are unexpectedly aligning toward the exact same direction in deep space.
Statistical calculations prove the chance of this peculiar orbital clustering happening purely by coincidence is almost zero. In 2016, two Caltech astrophysicists published groundbreaking mathematical evidence pointing toward an unseen ghost planet. Mike Brown and Konstantin Batygin discovered that an invisible gravitational titan must be tugging on these icy rocks. Calculations suggest this mysterious world, known as Planet 9, possesses 5 to 10 times Earth's total mass.
This celestial heavyweight is likely a super-Earth or mini-Neptune, a planetary type completely missing from our system. It orbits the Sun at a distance roughly 20 times farther than Neptune, drifting through eternal darkness. A single year on this phantom world takes between 10,000 and 20,000 Earth years to complete. When human ancestors were painting cave walls in Europe, Planet 9 was barely completing a fraction of its orbit.
To understand how it got there, we must travel back 4.5 billion years to our system's birth. During the early chaotic solar system, giant gas planets violently migrated, throwing smaller protoplanets out of position. Computer simulations reveal Jupiter's immense gravity likely catapulted this misplaced planet into the dark cosmic wilderness. Instead of escaping entirely, the Sun's faint outer gravity trapped the exiled world in a distant, eccentric orbit.
For billions of years, Planet 9 remained hidden in pitch-black space, completely invisible to early astronomical telescopes. The outer solar system is so vast that light from our Sun takes days to reach its frozen surface. Reflecting almost no light back to Earth, finding it is like searching for a single black marble in pitch darkness. Yet, its gravitational fingerprint is stamped clearly across the strange behavior of extreme trans-Neptunian objects.
Consider Sedna, a distant, frozen dwarf planet discovered in 2003 with a deeply puzzling, ultra-elongated orbit. Sedna never comes close enough to Neptune to feel its gravity, yet something pulled its orbit outward. Dozens of similar distant icy worlds have since been found, all sharing curiously tilted orbital paths. Without a massive planet holding them together, these orbits should have scattered randomly over billions of years. Instead, they remain strangely tightly clustered, as if restrained by an invisible shepherd world guiding their movement. Skeptics initially argued that observational bias created the illusion of clustering, claiming astronomers only looked in one direction. Subsequent rigorous statistical analyses proved the physical clustering remains statistically solid, even after accounting for telescope bias. Alternative theories emerged, suggesting a massive disk of icy space debris could explain the gravitational effects. However, calculations showed such a ring would require far more mass than exists in the outer solar system. Another radical hypothesis suggested a primordial black hole the size of a bowling ball is hiding out there. While mathematically possible, a planet remains the most plausible, scientifically sound explanation for all observed phenomena. Astronomers worldwide are now engaged in a high-stakes, highly competitive deep space hunt to visually capture it.
Scouring the night sky for Planet 9 requires extraordinarily sensitive telescopes capable of detecting faint infrared signatures. Because the planet is so distant, It moves extremely slowly against the dense backdrop of fixed background stars. Astronomers must compare images taken months apart, searching for a single point of light that has slightly shifted. The Subaru telescope in Hawaii, with its massive wide-field camera, has led the hunt across the northern sky. Its gigantic primary mirror gathers faint, ancient photons that have traveled for hours from the extreme outer solar system. Yet, huge swaths of the sky remain unmapped, leaving potential hiding spots along its predicted massive orbit. Enter the Vera C. Rubin Observatory in Chile, a revolutionary facility designed to transform deep space astronomical surveys. Equipped with the world's largest digital camera, it will scan the entire southern sky every few nights.
This observatory will generate vast mountains of cosmic data, tracking billions of celestial objects with unprecedented precision. If Planet 9 exists within its field of view, the Rubin Observatory's automated algorithms will inevitably detect it. The discovery would instantly rewrite every astronomy textbook on Earth, fundamentally changing our understanding of solar system structure. It would officially confirm that our solar system harbors a ninth major planet, far larger than Earth itself.
What would this mysterious world actually look like up close, hidden in deep, eternal shadow? Scientists speculate it possesses a thick mantle of water, ammonia, and methane ice surrounding a dense rocky core. Temperatures in its upper atmosphere likely plunge below minus 350 degrees Fahrenheit. Internal heat trapped since its formation might create subtle atmospheric glowing bands, invisible to human eyes. It could also host a system of frozen moons, carved by ancient gravitational interactions in deep space. These moons could experience intense tidal flexing, potentially maintaining liquid oceans beneath miles of solid ice. Finding Planet 9 would solve numerous long-standing cosmic puzzles that have stumped astrophysicists for decades. For instance, it could explain why the sun's spin axis is tilted 6 degrees relative to planetary orbits. Over billions of years, Planet 9's immense, distant weight may have slowly torqued the entire planetary plane. It also provides crucial context for exoplanet systems observed around distant stars across our galaxy. Astronomers have found thousands of super-Earths around other stars, yet our solar system seemed weirdly missing one. If Planet 9 is confirmed, our solar system would no longer be considered a cosmic anomaly. The search has also accelerated the discovery of hundreds of smaller, previously unknown trans-Neptunian icy worlds. Every sky survey aiming for Planet 9 expands our map of the outer frontier exponentially. What if the search ultimately fails, proving mathematically that Planet 9 does not exist? If no planet is found, physicists will be forced to rethink our fundamental understanding of gravity itself. Modified gravity theories could explain the orbital anomalies without needing a physical, massive object. Regardless of the outcome, the quest pushes human technology and observational limits to absolute extremes. We stand on the precipice of one of the greatest astronomical discoveries of the 21st century. Within the next few years, deep space surveys will provide a definitive, groundbreaking answer. Humanity's ancient desire to map the unknown dark drives us deeper into the cosmic ocean. Somewhere out in the freezing void, trillions of miles away, a silent giant continues its long, lonely orbit. It waits patiently in pitch darkness, carrying ancient secrets from the birth of our planetary system. Our telescopes are turning toward its predicted coordinates, closing in on the ultimate cosmic game of hide-and-seek. Soon, the shadows of the outer solar system will finally surrender their greatest, most elusive secret,
And when we finally gaze upon Planet 9, our map of home will be complete forever.